and I'm bringing you some amazing ladies of science for Women's History Month. I'm going to start with Catherine Charlotte de la Gardie, and she was a vaccination pioneer. She lived from 1723 to 1763, and even then she was pretty sure that this was a good thing. Born into Swedish nobility, Catherine Charlotte de la Garde became the lady-in-waiting to Princess Lavicia Ulricia in 1744 before marrying a count in 1748. An incredibly open-minded, brave woman of her day, Catherine was a keen supporter of the Age of Enlightenment, a period of political, philosophical, and scientific overhaul. We could use that. She is famous for publicly vaccinating her children against the deadly smallpox disease during a terrible outbreak, as well as encouraging local poorer women to do the same. At this time, inoculations were greatly resisted, so her act of confidence in the new medicine led others to follow suit, and most likely saving many lives. Catherine is also remembered for stopping the last witch trial in Sweden. In 1758, 18 people were arrested and about to go on trial for witchcraft, despite the fact that such accusations were becoming outdated. She is able to intervene in the legal process, preventing the innocent parties from further torture, as well as organize compensation for them, for their terrible treatment meant that they were unable to work. The accused were released without charge, and Catherine was hailed as a heroine. Catherine's sister-in-law was also an important figure in the world of science. Countess Eva Eckebald developed methods to distill and make flour from potatoes, which contributed to the reduction of devastating famines of that time. She was the first woman allowed to enter the Royal Swedish Academy of Sciences. And they say, smallpox was a widespread disease in the 18th century in Sweden, now eradicated. It was said to have caused the death of about 300,000 people between 1750 and 1800. 95% of those were probably children. The next one is Catherine Herschel, an astronomer. She lived from 1750 to 1848. Catherine Herschel was born in Hanover, now Germany, in 1750. She was the first professional female astronomer. In her early years, she had to tend to household duties. She was only able to leave home and join her brother William in England after he promised his mother to pay for a maid to replace her. At first, she spent much of her time singing in his concerts. He was a keen musician, yet soon William's interest shifted to astronomy. Caroline joined him in this new obsession and learned mathematics and science. She assisted him as he worked and helped record observations from his telescopes, undertaking many complex calculations from the findings. She also helped him build the telescopes. Their house had a room for grinding the shape of the mirrors, as well as polishing the glass. William discovered the planet later named Uranus in 1781, after initially thinking it was a comet. He was awarded the role of royal astronomer to King George III soon after this monumental find. Uranus was the first planet to have been discovered since Saturn, thousands of years before, so William became famous immediately. Brother and sister worked together for many years, surveying and cataloging the sky to discover more than 2,000 nebulae and stars. Caroline herself was the first woman to find a comet. She found 8 in total. She was eventually given a salary by King George for her role as her brother's assistant, being paid 50 lira, approximately $65 annually. I suppose it was a different time, however. Later, she was further rewarded by being made an honorary member of the Royal Astronomical Society in England for her contribution to astronomy, an amazing accomplishment, as it was an all-male group at this time. Caroline Herschel is rightly remembered for her own dedication to the science of astronomy and deserves the recognition and high praise she is awarded. Catherine Herschel's legacy is undoubtedly lasting. There are not only the discoveries in themselves, she was also an incredibly meticulous in cataloging and recording her discoveries, and in the transcription of astronomical data. Sherry Siru. This is Janet Marcet, a chemist. 1769 to 1857. No one at this time can duly estimate the importance of Miss Marsette's scientific works. Mary Somerville, the original scientist. Jane Marcet, the first female science writer, wrote a series of best-selling science books. Her most famous work is called Conversations on Chemistry, and it was anonymously published in 1806 to wide acclaim. This innovative book taught the fundamentals of chemistry by explaining key concepts through conversations between young female students and their teacher. Jane believed that public opinion was against the idea that girls should study science. She showed through her characters how willing young girls were to learn. After attending lectures by eminent chemist Humphrey Davy, she set to write a text to demonstrate this. She went on to write more influential books, including Conversations on Political Economy, which explained the complex ideas of economists such as Adam Smith. Jane was born in London to a wealthy banker and was homeschooled to a high level. She married Alexander Marcet, a political exile from Sweden and a physician with a great interest in chemistry. Together they carried out experiments at their home. Jane was part of an intellectual circle in London and immersed herself in learning. Her works became successful because she was able to present science in a way that was approachable and understandable, and available to the poor. Michael Faraday, the son of a blacksmith and later a hugely influential scientist, read her books and quoted them as the foundation for his learning. The next lady is Sarah Guppy. She was an inventor, and she lived from 1770 to 1852. Sarah Guppy was a prolific female inventor who lived during the Industrial Revolution. She was born in Birmingham, England, to a wealthy family and later married a trader from Bristol. Sarah and her husband became part of the circle of leading figures of the day, which included Isambard Kingdom Brunel, the creator of the Great Western Railway, the train line that linked London to Bristol. Sarah was interested in the engineering problems posed by bridges and made significant contributions to the design of several major projects. She made models of the Clifton Suspension Bridge for Brunel and patented a system of piling to anchor bridges properly and stop them from being washed away by floods or erosion. She is widely known for her inventions and innovative engineering ideas, as well as being a campaigner, writer, and esteemed businesswoman. Sarah seems to have loved coming up with ideas, and he has even been credited with the curious invention of a machine that can make breakfast and a bed that can be used for exercise. Sarah was a prolific letter writer and had strong ideas about animal welfare and town planning. She lobbied the Earl of Liverpool to close Smithfield Market, where animals were herded through the streets in dreadful condition. There are no statues of Sarah Guppy, no plaques that recount her inventions. In our culture, it is acceptable for women and their achievements to be buried, covered over, dismissed. That was Rachel Bentham and Alison Hallett. And the last one I'll give you in this batch is Sophie Germain, a mathematician born in 1776 and lived until 1831. Sophie Germain was a revolutionary female mathematician born in France in 1776. She lived at home her entire life and never married, yet dedicated herself to her studies with great passion. Early biographies state that her parents disagreed with how much she immersed herself in their extensive library, so she would read at night by candlelight to be undetected, teaching herself both Latin and Greek. She couldn't be stopped, however, and when Sophie was 18, she found a way to read the lecture notes from the male-only École Polytechnique. She wrote an end-of-term paper and submitted it, pretending to be a male student at the school. Her work impressed the teacher so much that when he discovered she was the author, he offered to oversee her learning. After Sophie corresponded with other great mathematicians, such as Carl Gauss, who was nicknamed the Prince of Mathematics, initially using a male pseudonym in case her true identity was rejected. Gauss was enthralled by her abilities and is quoted as saying, "How can I describe my astonishment and admiration on seeing my esteemed correspondent M. Leblanc metamorphosized into this celebrated person? when a woman, because of her sex, our customs, and prejudices, encounters infinitely more obstacles than men, familiarizing herself with problems, yet overcomes these fetters and penetrates that which is most hidden, she doubtlessly has the most noble courage, extraordinary talent, and superior genius. In the early 1800s, the French Academy of Sciences offered a prize to anyone able to prove a mathematical explanation of an experiment about vibrating plates. Sophie tried to explain it, yet despite her clear determination, lacked enough mathematical understanding at that time. She failed on both her first and second attempts, but eventually won the prize on her third try, after years of study and correspondence with experts in the field. Sadly, because she was a woman, Sophie was not celebrated widely for her achievements. Sophie also made impressive contributions towards establishing proof of one of the most complex mathematical problems of the day, Fermat's last theorem. In 1816, she was awarded a prize from the French Academy for her works on elasticity. Her theory explained that the patterns in sand formed when placed on a vibrating classic surfaces. This information was used in the construction of the Eiffel Tower. Before her death, age 55, she received a degree from the University of Göttingen in recognition of her excellent contributions. It matters little who first arrives at an idea, what is significant is how far that idea can go.